Sometimes I still forget. All right, we're recording now, so let's jump into Chapter 6. So Chapter 6 is all about memories and how we make memories, the neurological aspects of memories, and we end up with memory tips. So that's one of the groups as well, the memory tips for life. So as an example, this is one way you could cover all those memory tips, but you could also narrow in on one or two and talk about them in more depth in your presentation. Or you can talk about all of them in more depth even than I do here too. So a lot of your presentations are up to you, and there's a lot of freedom in there. So definitely send me emails, either through Canvas or through Outlook. If you're having trouble with your groups, like I said, I haven't seen anything. I don't think I've checked Outlook email yesterday or today, though. So if you emailed me over the weekend about your group on Outlook, let me know. Or wait a minute for me to check those. I don't think, maybe I did check them yesterday. I have so many Outlook emails for different schools, like the school I'm in, CGU, old schools I used to teach in, and this school. I try to go through all of them to keep in touch with people and like old students who want letters of recommendation or things, but sometimes I think I've checked my Salt Lake Community College Outlook email and I actually haven't. So yeah. All right, so memory. What is memory? Memory is basically how we describe the past things that have happened to us, or the knowledge of how to do things that can be recalled and used at any given time. So part of that is the process of encoding. And encoding is getting information into our memory. So how do we take our visual information, the visual sensation and perception that's happening right now, how do we take that and putting that into a memory? That's encoding. You could think of it as recording or writing a memory. So that's what encoding is. You're taking the raw data of your neurology, what's being fired right then, your sensations, your perceptions, your current hopes and dreams or fears or thoughts about what's happening now, and tying them into memory. So one huge thing that memory is influenced by, and we've talked about attention before, but memory is very impacted by our attention. So attention is the direct focusing of our mental resources on specific information. So when we attend to something, it increases our cognitive processing of that. So if you focus on, let's say you're doing two tasks. You're talking to your sibling through text on the phone, and you're also cooking dinner at the same time, some new recipe you haven't tried before. If you attend to the recipe, you're going to improve your cognitive processing on that. You'll probably do a better job. You won't make as many mistakes. Maybe you'll be a little faster. If you attend more to the conversation, you might have a better conversation. You'll remember more. You'll think of more things or remember more things to tie into that conversation, or be more present to help your sibling with whatever they might need. But a lot of what we're doing is, and a lot of what goes into our memory is first determined by our attention. If we don't attend to something, it's not going to be recorded in our memory. So when we're attending to things, we understand them better. So attention and memory are very tied to each other. We've talked about some of these before in sensation and perception. Selective attention, for example, is focusing on relevant aspects of a situation. So if you're at a party, focusing on the conversation you're having with the person that you're there with versus all the other noises going on around you. Ignoring irrelevant things. So focused attention or selective attention can happen if, say, you have multiple children talking to you at the same time. Well, that's still talking. I want a different example. Let's say selective attention here in the class stream. I'm talking, there's the slides up, and there's a chat box. If you selectively attend to the chat box and you focus on the messages there, right now there's not very many, you'll be able to cognitively process those things quicker and easier than if you tried to do all those three things at once. Divided attention is when you're trying to focus on more than one activity. So when you're trying to do both the texting and the cooking of dinner, or lunch or breakfast or a snack, whatever you want to do. So, or texting while listening to a lecture, a friend talking to you while you're trying to study. Hopefully that doesn't happen too much, but it looks like that's what's happening here. Sustained attention is related to some of these. With these, you've got to have this first, selective attention, in a lot of cases when you're using sustained attention. So this is maintaining that focus on one thing for a long time. So reading the whole chapter in one sitting is an example of sustained attention, or listening to all of lecture all at once. So if you're watching this recording after the fact, going through the whole lecture all at once, that is hopefully sustained attention, because if you're not attending to the lecture, you're not going to tie as many things into your memory. So if it's not attended to, it's not going to go into your memory, or it's not as likely that that's going to be in your memory. Executive attention is your attention on things that you're planning for the future. So this can be long-term goals. This can be a short-term goal. A short-term goal like cooking dinner, monitoring your progress. So as you're cooking a recipe, like I've done this, I've done this, I've done this, I still need to do this, this, and this. Dealing with errors or novel and difficult circumstances. So, oh, I was only supposed to put 1 teaspoon of salt, but I put 2 teaspoons of salt. How do I deal with that? How do you deal with that? There's not really any way to de-salt things, right? But if you put too little, you can obviously add more. So completing the class paper, for example, so your question papers, that requires sustained attention, executive attention. You have to plan on finding articles, well, coming up with a question and then finding articles and writing the paper, scheduling time around things. So a lot of this requires attention. So with that, here is a nice little Calvin and Hobbes comic. So clearly, Calvin has not paid attention these last 2 hours of class, and so he's hoping the teacher didn't say anything important, because then he would fail another test. So I love Calvin and Hobbes. One of the greatest comic series ever, I think. I've been reading it with my daughter too. It's pretty fun. So with that, memory is also influenced by the level we process things at. And so we've kind of divided those into 3 descriptions here in the chapter. So shallow processing, intermediate processing, and deep processing. So shallow processing is if you're reading something, you might recognize the shapes and letters in the words on the slide, for example. So that's really shallow. You're just noticing kind of what's there. It's not very deep at all. So intermediate would be you give that stimulus, whatever you're observing, a label. So if it's words, you recognize that word is a word. Or this slide, you recognize what the sentence says. And then more deep is think about the meaning of that word or about how it's relevant to you. So in this case, I've just shown 3 slides. If you looked at the shallow slide really shallowly, you'd say, oh, that's a PowerPoint slide. It's got the green background or the teal background Professor Richards uses a lot. Intermediate, you might read the sentence but not really think anything of it. You just kind of read it to read it. Oftentimes, for example, you might look at a terms of service contract and process it very shallowly. Oh, yep, there's words here, there's sections, different things, and you kind of really shallowly process that. At least that's how I do it. Probably not the best way. Then intermediate would be actually reading the thing, and then deep would be thinking about how that's relevant. Or for the lecture, tying this to some relevant example, tying this to something in your life, maybe writing it in your notes. That's a deeper way to process things. So you could imagine the things that are processed more deeply are going to be more likely to be written or encoded into your memories. So another way to do it is elaboration. So, and this is one example of deep processing. So elaboration is an example of deep processing, and it's forming correct connections around some stimulus as part of that encoding of the memory. So let's see, let's say you see a goldfish, for example. Shallow processing of that would be, oh, there's a fish. An intermediate might be, oh, that's a goldfish. And more deep processing might be that, oh, that goldfish looks a lot like the goldfish I had when I was 7 years old or something like that. Its name was Jake, and I was really sad when it died or something like that. I've never had a goldfish. Actually, now I'm trying to recall memories. No, I don't think I've ever had a goldfish. So thinking of any kind of example. So we're talking about memories here, tying it to a real world example that you can think of. One of your own memories, the time you used elaboration, is an example of elaboration. So it's like using more energy to think about that, think more deeply about whatever thing it is, whether it's the situation you're in. So you're at the DMV and something happens and you want to remember what the person said about something you've got to bring for next time or something like that. So think about it, think about where it is would be a deeper way of processing that. Plan to do that. Write it down. Those are deeper levels of processing, and you're more likely to remember in those cases. As we've seen with my terrible memory for recording the lecture, even if you do elaborate, set alarms, process things deeply, sometimes you'll still forget. So memory can still have problems, just as an example. So imagery is another way that we influence our memory. So visualizing material, whether it be a topic, like actually imagining the memory, like something that happened to you in life, that's a way to have a deeper processing and encode that memory better. A recipe, or let's say a shopping list. So you've got a shopping list, you want to remember everything on the shopping list. A better way than just repeating the words over and over again would be imagining the things. So I've got to get milk, imagine a jug of milk. I've got to get eggs, imagine a jug of eggs, a carton of eggs. I've got to get roast beef, imagine a carton of roast beef. So using imagery is really useful for humans, especially. We're very visual beings. With that being said, it is hard to do like a comparison with other animals. Say, hey, do you imagine, hey rat, do you imagine the maze in your head and think it out? Obviously you can't really ask, well, you could ask a rat that. They're really not going to say anything to you. But humans, at least, do a lot of imagery, and it's really useful for us. So with that, a lot of the people who hold the world records for remembering random words or historic dates or abstract images, they use imagery to remember them. So here are some of the record holders and what the records are for, like random words in 15 minutes. I'm not sure if this one... Okay, so this one is real words. There are people who have to remember nonsense words too. Well, they don't have to, they try. They practice memorizing nonsense words and the order and spelling of nonsense words, which I can't spell words that I use every single day, like the word certain, without checking spell check. So I cannot imagine doing that. So with that, one way to remember, and a lot of mnemonics are built on this, is to maybe do a visual walk around numbers. So imagine the numbers are really large. So someone tells you a phone number, you can literally imagine them as large numbers, or maybe a hopscotch pattern. You're literally hopping on numbers. You will be more likely to remember that phone number. Oh, I didn't never even notice that. They are all from Germany. I mean, it looks like it's 3 people. Simon Reinhardt has 2 of these records. Johann Mallow, I'm not sure if I'm pronouncing their names right, and Gunther Karsten has 1. So 3 people hold all these different records, but they're all using imagery was the main point. So it does work. Imagery does work. But yeah, that is interesting. They're all from Germany. Huh. So yep, using imagery can be really useful. We'll practice using a mnemonic later today in class, and it's a visual mnemonic. It's one that I've used before. I haven't found a way to visually remember people's names. If anyone has a mnemonic for using imagery to remember people's names, let me know, because I think that could really help. I kind of try to do that with students having their pictures on Canvas, so that I can see the name and see that picture at the same time. So that has been helpful, and it's kind of using imagery because I can remember that image of the student a little better, even if I don't always put together the name and the image in my head. That does help, but it's a little different. So giving the numbers an association to some image. So if there's ever a number sequence 911, you might put in your mind like a picture of a fire truck there as an example. And so then you're remembering that you're connecting it to something relevant, important, that's easy to remember, that's in your memory already. That's a good way to encode. So if that number is in the series of someone's phone number, you might remember 911 as 6 and then a fire truck. Just as an example of a way to visually connect some imagery with a number. So you could also look at the numbers as actual things or beings or objects. So you might say that here, thinking of pi, 3, you might see that as a chubby guy with a cane. A 1 walks to take out a window. Why was I saying this? Orders 15 hamburgers. I don't remember this example now that I read it again. It made sense to me earlier. It's getting late in the day. I guess that's why. Oh, I see. I see. The 1 is the cane. I'm like, how is there a cane in that number? Sorry, my son woke me up quite early today, and it is showing. So I apologize. Daylight savings time. We'll blame that. I'll blame daylight savings time. So with that, it works better for older children than younger, and a lot of that is probably because younger children have had less time to bring up visual memories and to record visual memories. So we'll talk about in a little bit how we really don't, it's very, very rare to have memories from before you were about 4 years old. So for younger children, it is harder to do this visual imagery and connect things because you're still making processes, you're still learning what is a fire truck to then make other connections to that. So here is a practice using a specific mnemonic. So this is called the method of loci or method of loci. It's also called the journey method. So it's a way that you can, it's a strategy to remember patterns of letters, concepts, ideas, random words. This method of loci or journey method can be used to remember a lot of different things that might seem unrelated to begin with. And there's a lot of different mnemonics. This is just one example. The song, there's children's songs that are mnemonics. I can't remember the one. 1, 2, buckle my shoe. So that one, 1, 2, buckle my shoe, 3, 4, shut the door. That's literally a type of mnemonic to try and help a child remember what are the things that they have to do in a day or in a task. So that's another example of a mnemonic. But there's countless mnemonics, and so I recommend, we're going to try this one out right now, but I recommend that you try out other mnemonics as well. You might find some that help you. I've tried a bunch of mnemonics to remember people's names. Some mnemonics work for people to remember names. So for example, people might associate a name with another person with that name, or that name with, say, an animal or some object that sounds like their name, and then they associate visually that person with that object and their name. So it ties more things together to that name. Those are other examples of mnemonics. But let's talk about this mnemonic, the method of loci. So essentially, you imagine a place that you already know. So some place that you're really familiar with, that visually you can think about it, it's a place that you can walk through. So it could be a park that you know really well. It could be your own home. It could be the home you grew up in. It could be um, just a place that you know really that you're really familiar with, that it's really easy for you to recall where things are, the distance between places. So I can stand by this counter and reach to this counter kind of thing. So someplace that you know really well. So that's the first thing. Then you can take random words. So this is just a list of random words. You can also do this with, say, a shopping list. So you could have a shopping list, and to remember it, you might use this method of loci. So here's our example words. One is bottle. So you say, okay, I'm walking through this house, or I actually, for when I use this method, I use the house that I lived in when I was in high school. It was in Indiana, which isn't really relevant, but that's where I usually use. It's easy for me to remember all the different places in this house. So to remember this list of random words, I would associate these random words with part of that house. So let's say I'm coming home from school, up to the front door, there's a bottle on the ground. So let's say it's a 2-liter jug of Baja Mountain Dew, which is something I would have drank way too much of in high school. Um, and it's out now. Like, you can buy it in the stores. When I was in high school, you couldn't. So there's a bottle there. So I'm associating that bottle visually with the doorway, the entryway of this house. Then I open the door. At the inside of the door, there's a cup there. So that's a pretty easy association. Take the bottle, take the cup, pour some Mountain Dew in the cup. Then, as I'm walking in, one of the first rooms after the entryway is the living room. So there's a coffee table there. Like, all these things and objects in this place are really easy for me to remember. It's not hard for me to recall these things. So that's why it's good to associate this random new list with this place that I know well already. So on that coffee table, there's some paper. So I'm visually thinking about this as me, like, walking through the house. So I walked up to the front door, there was a bottle. I opened the door, there was a cup. I look into the living room, there's paper on the coffee table. And then I see near the back door, there's some sand. So in my mind, I might even make a story like, oh, my sister was probably in a sandbox and dragged sand through the house. And I walk into the kitchen. On the kitchen counter, there's a box. Maybe it's an Amazon box. I don't know. There wasn't, I don't know, was there Amazon for books when I was in high school? I never did try to use it, but yeah, I don't think there was. Well, that's how old I am. Then, also in the kitchen, near the box, is a fork. That makes sense in the kitchen. Um, then maybe across on the other counter in the kitchen, there's a staple, so on and so forth. So that's how you use the location that you're familiar with. You could do this with a park, a trail that you're familiar with. Uh, a house is pretty useful because there's often different rooms in a house, different things like couches in one room versus kitchen chairs in another room. So you can sometimes associate the words better with things in different rooms. But really the key is associate this random list with a place that you know well. So practice that yourself for just a second. I'll just give you like 3 minutes to kind of make your own examples of this list, of your own location. And definitely also ask me questions if you're still a little confused what we're going to do. And then in a minute, I'm going to test you on another list of 12 random words, and I'll actually time you for, I think it's like 2 minutes I'm going to give you to memorize those words in that order using this method. So practice on this list, and then I'll put up another list and give you 2 minutes to try and memorize that in order, and we'll see how many people get it right, like get the list in the correct order and all 12 words. All right, take another 30 seconds or so to finish up trying to memorize these 12 words or using it as an example. All right, so hopefully you kind of understand now and you've had a little bit of practice on associating these random words with some location. Does someone have a location dissimilar to what I was using? So I used a house. Did someone else use a location that's very dissimilar to a house and wants to kind of give an example of how they were associating these with that location? Maybe everybody was using a house because it was my example. Or someone's typing and I don't know. That's one thing I wish this had, is a thing letting me know when students are typing. Oh well. All of these different broadcast softwares, none of them is completely perfect, but it does seem that this one has less drops and freezes and stuttering, so that is a good thing about it. All right, so I'm going to put up another couple words. So if you have the slides yourself, don't jump ahead and don't cheat and bring it up or write it down. So what I want you to do is I'm going to bring up another list of 12 words, basically the same setup. So do your best to use that method of loci to associate the different random words with something in your location. Uh, the same location that you are using is probably best. So try to remember them in that same exact order. And then we'll see in a few minutes how many you got right. So I'll put it up for, I think, like 2 minutes, and then I'll take it down. Then you can write it down. Hopefully you get it in the right order, and then we'll see who was correct and who was not. So I'm going to pull up my timer here. So hopefully everybody is ready. Let's go on to the next slide, and I'll actually mute my video. Well, mute my video. I'll mute my audio and video to be less of a distraction. All right, so 2.5 minutes. Learn these words. You've got about 1 minute left. Oh, I'm not sure. I think I may have had my microphone off for a second there. So if so, sorry if I'm repeating this again. Um, but take a minute now, grab a piece of paper or open up a new window, write down those 12 words in the same order that they were on that list. So I'll give you a couple minutes to do that. So write down those words in that same order. Don't look back at the slide. Just do it from your memory. All right, hopefully you've got those written down now. I'm going to flip back to the slide. Then in the chat, basically tell me how many that you got in the correct order. So here are the words. So these were the ones that you were supposed to learn using the loci method. So if you've got cake, top, sink, shoe, chicken, that would be 2 missed ones, right? So it's got to be in the right order as well. So let me know how many you got correct out of 12. If you knew there was one, like you missed 4 and you like skipped that, and you went cake, top, sink, shoe, that would just be 1 miss. So calculate how many you got right and how many you got wrong, and just put it in the chat box so we can see about how well people did with the loci method. Yeah, it still counts if you misspelled a word. Spelling only counts on question papers. Unless you spelled stitch like lamp, then that doesn't count. All right, so we've got one perfect score. We've got a couple 8 out of 12s and a 6 out of 12. I usually, when I actually do this, because I mean, it's kind of unfair since I chose the list of words, I usually get close to 7 or 8 out of 12. I do use this method sometimes to remember things like lists, such as shopping lists. Yeah. So that is, hopefully other people tried it too, rather than just watching all of us trying it or sitting around while the rest of us tried it. So yeah, that's pretty normal for what I expect. I do this in a couple of my classes. I actually use this as an experiment in one of my classes with students. One group of students does the loci method. Another group of students just tries to rote memorize, so repeat the words after each other multiple times for the 2.5 minutes. And the loci method always does a little bit better on average than the just repetition method. So great work. And let's continue talking about memory. So memory is influenced also heavily by understanding it, not just memorizing it as a list or memorizing words and definitions, but by making it meaningful, by understanding it enough that you can personalize it, that it can be relevant to you specifically. For example, with the content in the book. So if you really understand what's going on, the processes, the connections, then you'll remember the thing better. So when students connect it to stuff from their other classes, they will be more likely to remember it. When you understand more about the visual system, for example, or more about neurology, or more about epigenetics, it's easier to remember the couple facts that I really want you to take away from the class, as an example. Me giving multiple different kinds of examples in class can be helpful. Using one example throughout talking about experiments, for example, can make it easier to connect and make it meaningful, like the content on that topic. So understanding material is very useful for deep processing into your memory. So how is memory stored? What is it actually like? Is it in little glowy balls in your brain on shelves like an Inside Out? Well, no, but that's cool in the video. And your memory also isn't like a photograph. It's also not like a videotape. Memory is stored in really interesting ways that will hopefully be pretty understandable to you, because we've been talking about how neurons work together for a couple weeks now. So memory storage is essentially just the retention of information over time, and that's really important for any cognitive processes, really. So one type of memory that we'll talk about is sensory memory. This is information from the senses about the world. So remembering our visual inputs, so remembering what we see, remembering things that we hear. Sensory memory, like the aspects of what we're seeing getting into our brain, into our conscious experience, and into our memory. This sensory memory only lasts a few seconds, so it's really quick. So essentially our neurons are holding on to, or you could say, are keeping a store or kind of a reverse buffer. So if you're trying to load a YouTube video, it might buffer and kind of store some of that material ahead of you, ahead of what you're watching. Our brain kind of does this in an opposite way. So what you're seeing, it kind of stores what you've seen for the last second or two to then process and put it into your perception. So it only lasts a little bit. So that's sensory memory. It's a specific kind just about the senses that are getting input. So with that, iconic memory is visual sensory memory. So this is how we can see a word like love here spelled out in sparklers, or if you try to write it, draw a circle or write your name. It's because of sensory memory is holding on to where that sparkler was before that you can then see that word. So if you go a little too slow, you won't be able to see a whole word, maybe just a couple letters at a time, because the sensory memory only remembers a little bit of what you just experienced. So essentially your sensory memory is literally holding that sensation, those inputs of that light, and it's still holding that. In a way, you're kind of still seeing that, even though the actual glow of that sparkler is gone. So that's sensory memory. Short-term memory is different than that. It's the information that's retained up to about 30 seconds without any kind of rehearsal or adding meaning to it. So like the last 30 seconds that just happened to you, you can probably recall any of that last 30 seconds before it leaves your memory. So this is called short-term memory. More recently, well, I'll get to that in a second. So short-term memory is limited in early childhood. So for example, a 2-year-old might be able to remember a 2-digit sequence, like you tell them a random number, 1-5 or 9-8 or something like that. They might be able to remember that, but they probably won't be able to remember 9-8 5-4-3. I can actually remember that. 9-8-5-4-3. I just said it. So a 7-year-old can probably remember more up to 5 digits. So it seems like short-term memory increases up to about that age, and then it kind of hits a point where it's not increasing anymore, where we get to remember about the last 30 seconds without doing anything with it. So that's our short-term memory. It's the last 30 seconds kind of in a buffered chunk, and it kind of like fades out of our memory unless we work with it, unless we manipulate it, we try to repeat it, we try to make it meaningful. So a lot of what I just said might be now out of your short-term memory and gone forever, unless you rewatch the video or try to recall and then make this bit meaningful. It might help your neurons fire and remember some of the things I said before. So with that, there are still some slow, steady gains in the teen years, but it gets about to that point of remembering about the last 30 seconds without working with that information. So short-term memory is passive. It's like things that are being automatically set on shelves and then coming off the shelves. Dory is a really good example of this. The short-term memory for Dory just comes and then goes. So Dory can remember some things that have just happened, but then they're just gone. So I think that buffer example is a good one too, a reverse buffer. So you've got that 30-second chunk, and then it slowly is going away. And so that 30 seconds is gone, and it's continuously getting the next 30 seconds and reverse buffering that. So it appears and disappears based on our attention. If we're attending to something, it can be in that short-term memory. If we're not attending to something, like in my peripheral vision here in this room I'm in, there's like flowers completely out of frame, but flowers like that way. There's cats over here. So if I attend to those like I just did, now that's in my short-term memory. But when I'm not attending to those aren't part of my short-term memory. So it appears, our short-term memory does appears to have about 7 plus or minus 2 spaces for information. So you could say 7, so 5 to maybe 9 shelves to put things on in this buffer. So how can we improve that? How can we improve our short-term memory? One way is to chunk things together, group things together so that multiple groups that are meaningful together can fit on one of those shelves together. So rather than remembering a whole long phone number as individual units, like how many numbers are in a phone number? If we're not counting the area code, 7, right? Yeah. Had to recall some long-term memories there to remember how many numbers are in a phone number. Anyway, so if you've got only 7 shelves, say 7 shelves 5 times fast, that's difficult. So if you've got only 7 shelves, for your short-term memory, putting each of those numbers individually can fill up your whole short-term memory, and then you have no space for new information coming in. But if you chunk those numbers together, like for example, if there's a sequence of 911, you chunk it together and you make it meaningful and connect it with an image of a fire truck, put that whole section on a shelf, then you've remembered those 3 numbers in only one chunk. So you're still remembering the phone number, but now you have extra spaces. So chunking is grouping items into one unit. So you might remember a phone number as a phrase or altogether the whole phone number. So I remember my phone number as essentially just the last four numbers. So it's kind of chunks. The area code, the first three digits, and the last four digits. That's how I remember my number. It's in three chunks, essentially. So rehearsal can help improve your short-term memory as well, because you're taking these things that are on the shelf and you repeatedly look at them. You can imagine it that way. Or that buffer is going, so before that's left, you come and put that back in your short-term memory. And then before it leaves again, you grab it again. So you're repeating information. So that makes it more likely that it's going to go into long-term memory. So this is all very related to what we described today as the working memory. And so you could think of the working memory as the mental workbench. So we've talked about Inside Out today in relation to memory. Sometimes I like to imagine that mental workbench being the table that was in front of the Inside Out characters. So you have Joy. Where was our, maybe I go forward. Did I put a picture of Joy? No, I did not. So here they're in Riley's head. They've got this table, they've got this screen. So the short-term memory would just be things slowly passing by. The working memory, on the other hand, is once those things are passing by, you grab it and you put it on this workbench and you work with it. You repeat that information, you pull up other long-term memories and connect it with that. You connect it with other aspects of your personality, similar to how they talk about the personality islands in Inside Out. So you make decisions based on this information that's right in front of you. You manipulate the information. You solve problems with it. This is how let's say you're listening to someone speak. You're calling back information from before, calling back long-term memory to understand the language, what's being spoken to you. So our working memory is essentially another way to describe our conscious experience. So where you live essentially in your working memory. You're working with the things that are happening to you. I'm saying things and you're hopefully making connections. So you're working with this information. Maybe you're writing notes. Maybe you're thinking about other examples that are relevant to you. So that's what working memory is. It's the cognizant, conscious, working with the things we're attending to at the time. So the prefrontal cortex is obviously going to be really heavily involved in this process, and it is involved in a lot of aspects of life. The working memory is used in all aspects through life, and it improves through adolescence and into adulthood. And then after that, it's kind of a stable, consistent skill of your working memory. It can get a little better, and it's not till the middle to late 80s that your working memory ability really drops off. But if you're working with your working memory, it can keep its capacity for a long time. So let's watch this video. It's, if I remember, a TED Talk about the working memory. It might be another lecture, but it's like a lecture TED Talk style thing. So this will give you a lot more information about working memory and some other examples beyond what I just gave too.
So yesterday, I was out on the street in front of this building, and I was walking down the sidewalk, and I had company, several of us, and we were all abiding by the rules of walking down sidewalks. Okay, we're not talking to each other, we're facing forward, we're moving. When the person in front of me slows down, so I'm watching him, and he slows down, and finally he stops. Well, that wasn't fast enough for me. So I put on my turn signal, and I walked around him. And as I walked, I looked to see what he was doing, and he was doing this. He was texting, and he couldn't text and walk at the same time. Now, we could approach this from a working memory perspective or from a multitasking perspective. We're going to do working memory today. Now, working memory is that part of our consciousness that we are aware of at any given time of day. You're doing it right now. It's not something we can turn off. If you turn it off, that's called a coma. Okay? So right now, you're doing just fine. Now, working memory has four basic components. It allows us to store some immediate experiences and a little bit of knowledge. It allows us to reach back into our long-term memory and pull some of that in as we need it. Mixes it, processes it in light of whatever our current goal is. Now, the current goal isn't something like I want to be president or the best surfer in the world. It's more mundane. I'd like that cookie. Or I need to figure out how to get into my hotel room. Okay? Now, working memory capacity is our ability to leverage that. Our ability to take what we know and what we can hang on to and leverage it in ways that allow us to satisfy our current goal. Now, working memory capacity has a fairly long history, and it's associated with a lot of positive effects. People with high working memory capacity tend to be good storytellers. They tend to solve and do well on standardized tests, however important that is. Okay? They're able to have high levels of writing ability. They're also able to reason at high levels. So what we're going to do here is play a little bit with some of that. So I'm going to ask you to perform a couple tasks, and we're going to take your working memory out for a ride. You up for that? Yeah. Okay. I'm going to give you 5 words, and I just want you to hang on to them. Don't write them down.
So do try to do this. Do try to remember these 5 words. You can use repetition. You can try to use the method of loci. Try to remember these 5 words in these orders too.
Just hang on to them. 5 words. While you're hanging on to them, I'm going to ask you to answer 3 questions. I want to see what happens with those words. So here's the words. Tree, highway, mirror, Saturn, and electrode. So far, so good? Okay. What I want you to do is I want you to tell me what the answer is to 23 times 8. Just shout it out. In fact, it's exactly. All right. I want you to take out your left hand, and I want you to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a neurological test, just in case you're wondering. All right. Now what I want you to do is to recite the last 5 letters of the English alphabet backwards. You should have started with Z. All right. How many people here are still pretty sure you've got all 5 words?
All right. So who in the class, either by raise of hands or maybe just put in the chat box, I think I've got all 5 words, or like 5, or if you can remember 4, just put the number 4. So, and then we'll see if you were right. All right, so 5, 5, and 5. All right, so would someone, actually, all of those of you who just wrote 5, could you list out the 5 words in order, and we'll see if they all match up, and I will do that as well from what I remember. It'd be nice if I could spell things right. But it's nice to have computers that will spell check for you. All right, it looks like all of us who wrote it out here did it correctly. So it was tree, highway, mirror, Saturn, and electrode. So the way I did this was not the method of loci, but I did use visualization to do it. So visualization works for me really well. So when he said tree, I imagined a tree. I imagined a deciduous tree with brown trunk and green leaves on top. And then he said highway, so I imagined, well, I'm driving on the highway past this tree. And then he said mirror, so I thought, oh, cars have mirrors. So in my mind, I looked at my side mirror. And then in my mirror, he says Saturn. I see Saturn in my rear view mirror. And at that point, because I listened to a lot of like 80s synth music, it all turned like very synthwave-esque 80s colors. So the highway was like purple and Saturn was red, and there was lines in the sky and things. And so the electrode fit really well. It was spinning around Saturn. So that is how visually how I remembered this and how I connected these things together to something meaningful. Did anybody use a method other than visualization? Did anyone just repeat things or use something else to try and remember these 5 words? So Celestial says, I just pictured them all in a painting, but electrode was difficult, so it stuck with me. I didn't know how it would fit in the painting. Yeah, that's totally fine. But yeah, really, really good example. So it was still visual example, and for you, it was a painting, and all these things were kind of added to the painting as they were talked about. So Don also visualized, but associated them with memories. So that's another form of deep processing, is one, this visualization, and then associating this visualized thing with memories. Saturn, you almost forgot because you didn't have a memory to go with it. Okay, so Saturn's probably not Don's favorite planet. So that's one way I connect Saturn. It was my favorite planet, and probably because in like 3rd grade I did a little report on it in a class. So literally just remembered that, recalled it from my long-term memory. So look what happens. You remember so many things when you're talking about memories. But yeah, really great examples, both Don and Celestial, about how you remembered these things, what process you went through to process these. Your report was Mercury. Nice. Is Mercury now one of your favorite planets? I'm just curious if it is. 3rd grade was actually here in Utah, so I wonder if that's still. Oh, that's so funny. That would be an interesting study to see how many people's favorite things were something that they say did a report on in school, in elementary school. So, yeah, funny. All right, so let's finish watching this video, get a couple other examples of working memory and how it's relevant in our lives. But thanks for trying these exercises out.
Okay, typically we end up with about less than half, right? Which is normal. There'll be a range. Some people can hang on to 5, some can hang on to 10, some will be down in 2 or 3. What we know is this is really important to the way we function. Okay? And it's going to be really important here at TED because you're going to be exposed to so many different ideas. Now, the problem that we have is that life comes at us, and it comes at us very quickly. And what we need to do is to take that amorphous flow of experience and somehow extract meaning from it with a working memory that's about the size of a pea. Now, don't get me wrong, working memory is awesome. Okay? Working memory allows us to investigate our current experience as we move forward. It allows us to make sense of the world around us. Okay? But it does have certain limits. Now, working memory is great for allowing us to communicate. We can have a conversation, and I can build a narrative around that. So I know where we've been and where we're going and how to contribute to this conversation. Allows us to problem solve, critical think. We can be in the middle of a meeting, listen to somebody's presentation, evaluate it, decide whether or not we like it, ask follow-up questions. All of that occurs within working memory. It also allows us to go to the store and allows us to get milk and eggs and cheese when what we're really looking for is Red Bull and bacon. Got to make sure we're getting what we're looking for. Now, a central issue with working memory is that it's limited. It's limited in capacity, limited in duration, limited in focus. We tend to remember about 4 things. Okay, it used to be 7, but with functional MRIs, apparently it's 4. We were overachieving, all right? Now, we can remember those 4 things for about 10 to 20 seconds unless we do something with it, unless we process it, unless we apply it to something, unless we talk to somebody about it. When we think about working memory, we have to realize that this limited capacity has lots of different impacts on us. Have you ever walked from one room to another and then forgotten why you're there? Okay. You do know the solution to that, right? You go back to that original room. Okay. All right. Have you ever forgotten your keys? Have you ever forgotten your car? Have you ever forgotten your kids? Okay. Ever been involved in a conversation and you realize that the conversation to your left is actually more interesting? All right. So you're nodding and you're smiling, but you're really paying attention to this one over here until you hear that last word go up and you realize you've been asked a question. And you're really hoping the answer is no, because that's what you're about to say. Okay. All of that talks about working memory, what we can do and what we can't do. We need to realize that working memory has a limited capacity, and that working memory capacity itself is how we negotiate that. We negotiate that through strategies. So what I want to do is talk a little bit about a couple of strategies here. And these will be really important because you are now in a information target-rich environment for the next several days. All right. Now, the first part of
So I definitely recommend finishing watching this video on your own time to find other strategies for working memory. Some of them we are talking about, but not all of them. So definitely a good video to learn a little bit more about how to build your working memory. But hopefully that gave you a lot of good examples to see how much of our life working memory impacts. It is essentially where we're living. It's our conscious experience. It's how we do a lot of things and work with information here in the now and relate it to information in the past towards our goals in the future, things like that. So for working memory, I don't have my notes up, but I feel like these pictures were here for a purpose, for another example on working memory. But at the moment, my working memory is not working, and I cannot remember why. So good working memory is correlated. So it probably shouldn't be equal. It should be something saying that there's a correlation between good language ability, like the ability to understand language, math skills, problem solving. So not just things like math problems, but also other problems in the world, or problems with, say, like chess or things like that, and reasoning. So the better your working memory is, the better you will tend to be at these other fairly difficult and cognitively intensive tasks. So working memory is a really good thing to try and work on and focus on and do better at. So now let's jump to the last aspect of, well, the last kind of storage, memory storage thing, long-term memory. So we talked about sensory memory, so hopefully you remember that. That's what your senses are seeing and can store for a very short time. Long-term memory, so started with sensory, then we talked about short-term. We talked about the more modern term of working memory that kind of absorbs a lot of what short-term memory research did and was talking about. So not many researchers talk about short-term memory in that same way. It's kind of an aspect of working memory now, as it's discussed. And then there is long-term memory. So long-term memory is a relatively permanent aspect of our memory. So the things that you remember, like you did a report on mercury, Don, that is in your long-term memory. It's relatively permanent. You will probably be able to remember that until you are until the day you die, essentially. I never want to bring up death in classes, but yeah, you'll remember it forever. I should have just said that. You'll remember it forever. So sorry about that. Hopefully I don't give anybody, including myself, existential crises while we're having class right now. So with that, long-term memory has a really large capacity. So this is another good connection to Inside Out. When in Inside Out they saw long-term memory storage, it was what appeared to be miles and miles of shelves filled with the little memory balls from Inside Out. So with that, the quantity and quality are really dependent on the strategies used to remember it. So that's another maybe connection or visual example you can think of. In Inside Out, some of the memories were kind of dull and gray, and some were really bright and vibrant. So those that were bright and vibrant were the ones that were more easily remembered or were clearer memories, were recalled very often. And you can make your memories that clear and bright and whatnot if you use a lot of different kind of memory strategies. So some that we've been talking about, some that you might look up yourself, some that we'll talk about probably next week or next Tuesday when we finish this chapter. So with that though, anything that gets into your long-term memory is probably going to be permanent. So the capacity of your long-term memory increases in middle and late childhood, and it probably grows in adolescence as well, but it's a little hard to measure that change. So it stays pretty consistent from about late childhood all the way through adulthood. So long-term memory and working memory are always working together. So here is a more modern model of how different aspects of our memory are working together. And we won't go into a ton of detail on each of these. Just gives you an idea that working memory works to make long-term memory work, essentially. Visual Spatial Sketchpad is essentially the working memory aspect that does visual things. So when you're doing an imagery thing, you're using that Visual Spatial Sketchpad. Phonological loop is sound, so the sounds that are around you, language that you hear, if you're thinking of words. Episodic buffer is kind of like a connection between long-term, well, all of these are connected to all the other pieces, but it's like this is the episode, the things that are happening around you. You're in this room. Well, I'm in a room. I'm in my office room. It's evening time. Things like that. And then the central executive, you can think of that like prefrontal cortex, like planning, like what's going on, what are goals that are driving this. All of those are aspects of working memory that are working together to then pull things from long-term memory, like pull what is the episode, what was happening during my first kiss, what was I seeing, what was I hearing at that time. And then pulling it up to the central executive to then say, okay, now in this context of what's happening in the lecture today, how much of that am I going to share? So thank the central executive for sometimes reminding me not to share too much about my own life, right? Sometimes I do though. So there are two different kinds of memories that we store in long-term memory. One is implicit and the other is explicit memory. So implicit memory is a memory without our conscious recollection. So it's there in our long-term memory. It is stored and it's useful and it works. It's for things like skills and procedures, like being able to pick up and use a pen. That is something that would be in your implicit memory. Being able to shift on my motorcycle is in my implicit memory. So I don't have to like consciously think like visually, like how do I shift and things at the same time as I'm doing it, right? So it's in my implicit memory, which is part of my long-term memory. Explicit memory is usually what we're talking about when we ask, hey, do you remember this thing? Do you remember your first kiss? Do you remember your book report in 3rd grade on a planet? Do you remember which planet you did? That would be more of an explicit memory. So the conscious memories of facts and experiences. So I remember the first time I pole vaulted, the time my brother broke his arm pole vaulting, those kinds of things. Those are explicit memories. And this is usually what we're talking about when we're talking about memory. But implicit memory is a type of memory too, that memory of how to do things, how to ride a bike, how to use a spoon, how to use a pen, how to shift your car or motorcycle. And explicit memory is like the kind of episodes of your life that you watch as like a film in your own mind to kind of recall and remember. And it increases as we grow older too. So a 6-month-old only appears, again, it is very difficult to do research on young children Their language capacity isn't high enough yet that you can really talk to them a whole lot. So a lot of this is based on things like visual preference methods and things like that. So it is hard, and it's definitely correlational data, but it seems that 6 months old only can remember in their explicit memory about the last whole day as whole episodes. 9 months old, it seems that they can remember about a whole month. 10 to 11 months old can remember about 3 months. 13 to 14 months old can remember about 4 to 6 months. 20-month-olds can remember about 12 months earlier on in their life. So this is one reason humans don't tend to have memories when they're very, very young. It's actually really, really rare for people to have memories from before they were 4 years old. Part of the reason for that is your brain is learning in this time, in that first 6 months, in that first 20 months, your brain is literally learning how to make connections. It's making lots of connections, new dendrites, new axon branches, and learning how to make memories. So that's one reason oftentimes we don't have memories for that early on in life, because there's nothing to connect it to. There's nothing to make it meaningful. We have to start making meaning and then attach things to that, make more and more memories to then make more and more memories. So it's kind of this developmental process of building memories on top of memories. So that's one reason that it's so hard to remember things that early on in life. I think the earliest memory that I've had a student tell me that they had was, I think they weren't sure if it was when they were about 2 or like 1.5. That's about the earliest memory it seems students have. And we'll talk about, is that a real memory or not? We can talk about that in a little bit. So with that, most research does suggest that explicit memory doesn't really exist in the sense of you can't really think back and remember things earlier than 1.5 years old. And it is really rare to remember things earlier than 4 years old. So if you have memories of the time when you were 2, that's pretty neat. Not as common. My first memories are somewhere between 4 and 5. Is when my first memories really start. So my son, who's 3 years old and hasn't and went to Disneyland only like his first 2 years of life, he will probably never have memories of going to Disneyland. But if I show him pictures of him at Disneyland, he might then create memories of Disneyland. So, but we'll talk about that and memory manipulation. We might not get to memory manipulation until the next class. It sounds really sinister when I say it. I felt like it sounded really sinister. Memories are getting changed all the time, essentially. So, spoiler alert, memories all the time are getting changed and revised and added to. And part of that is because of the ways we store memory. So let's take a quick break right now before we talk about storage of memory. What time is this class supposed to end? It's 9:50, right? So we definitely have time to talk about storage of memory and then break up into groups. So it is 9:50, right? The end of this class. For some reason, I cannot call in my long-term memory right now. But I think that's the case. All right, so yeah, let's take a quick break and be back here at about 8:25. So be back here at 8:25 and we'll talk about how memories are actually stored. And then maybe we'll be able to talk about how memories can be changed and manipulated through just the normal process of remembering things. So take a quick break, be back here at 8:25. Did everybody receive my messages about the video to watch? The 9-minute video on YouTube about memory? Okay, perfect. So just let me know when you're finishing up with that video so then we can talk about it as a class. Sorry about that. I'm glad I did get my internet fixed. All right. Hopefully everybody's finished with that video now. If not, sorry about that. Sorry, my internet died. I'm wondering what it looked like to all of you and then what it'll look like on the recording as well. It says the recording is still going, so hopefully the server was catching it and I don't have two files to put together. My computer is very slow at rendering videos, so I don't really want to have to put two files together. So hopefully I don't have to. But a lot of that was review, some additional examples that hopefully help clarify some things that we've talked about so far today. But memory is really important to everything that we do, especially when we're talking about working memory. So what is happening at the neural level? Well, we're not going to dive terribly deep, but I do want to give you a little bit of a sense of what's happening at the neural level to create memories, because it's not that. So essentially, memory is whole networks or circuits of neurons working together, kind of, not exactly, to repeat the same neurons activity that were happening when a memory happened. So if we're talking about remembering a first kiss or remembering learning how to drive, a lot of the neurons that were active during that time are going to be reactivated as we're remembering that thing. So when we sleep, some of our memories from the day are re-encoded. The connections between dendrites and axon branches are strengthened. So it makes it easier for when we get something priming a memory for that whole circuit or whole network of neurons to fire again together. So that's essentially what a memory is a circuit or a set of neurons firing together to essentially relive that same experience. It's not all the neurons that were active at the time. It may not even be most, but a lot of the neurons that were active during the time of the event are reactivated during the course of remembering something like a first kiss or something like that. So it's not that somewhere in your brain you have a neuron that remembers, like this specific neuron remembers that you did a report on Mercury. That's not how memory works. It's that memories are being put together. So that memory of Mercury is also connected to other memories of Mercury. Aspects of it being your favorite planet, for example. That memory of your first kiss is probably connected to maybe a memory of a first date or a first time you saw that person or a breakup later on if that happened. So they are connected to other network, or the network of that memory is connected to other neurons that were active during the event, but they also get connected to other similar events or other similar processes or other similar kinds of memories. So a lot of your memories about your significant other are going to remind you of other memories of your significant other, as an example. Memories of your pet that you have are probably going to also remind you of memories of other pets that you have, because they're stored in similar networks, essentially, in your neurons. So memories are probably in groups of about 1,000 neurons, it seems, for humans. So again, it's really hard to map out on humans exactly how many neurons are involved in any given memory within that network, but it seems around somewhere like 1,000. So single neurons can play a role. So when we talked about sensation and perception, we talked about neurons that respond to shapes or colors or motion. So some of those neurons might respond to, some of those feature detectors might respond to faces specifically. So you might have a couple neurons that when they're activated, when you're trying to remember or you see a picture of someone's face, it starts a whole network of neurons and starts a bunch of memories. So when you talk about something like being primed or triggered for a memory, essentially what that means is there's one of those cells within that network that gets primed or triggered, that gets activated, and starts that whole cycle or that whole network up to inspire that memory. When it's something good, that's great. When it's something traumatic and hurtful or harmful, then that can be really obviously hurtful and harmful. It's in how I described it, obviously. So, but that's how memories work, is these networks of neurons, a lot of them were involved in the making or the experience of that memory. So neurotransmitters are those chemicals at the synapse that the electrochemical signal comes down the axon, it goes down the axon branch, and here it will release that chemical into the synapse, which will then connect with the dendrite or the cell body of another neighboring neuron or multiple neighboring neurons, and allows it to communicate. So these chemicals help in establishing memory. Certain chemicals make it so that the memory will become stronger, or the connection will become stronger, so the receiving neuron will be more likely to fire when it gets the messages from this neuron. So a lot of that is really complicated processes about how these cells actually work with each other. We don't really need to go into more detail than that. You can find more videos online on YouTube that go into that in a lot more detail, like at the cellular level, which neurotransmitters lead to what responses in the following cells. So if you think that would be helpful for you, feel free to do that extra research as well. But essentially, all you need to know is that the responses that you're getting at that synapse, the types of chemical, is going to lead to a memory being more or less likely to happen, or that connection being more or less likely to be strengthened. So one way that we learned a lot about these neural networks is actually from this little sea slug. So these sea slugs have about 10,000 neurons, which is quite a lot. So, but it is like a manageable number. So if I had $10,000, I can imagine that. I can imagine $10,000. I'd buy a motorcycle, Yamaha Tenere 700. That's what I'd buy. And then have a little left over for extra mods and camping gear to then go on a motorcycle camping trip. I'm getting too many of those memories of motorcycling coming up. I'm getting distracted. I'm distracting myself. Anyway, a sea slug has a manageable number of neurons. That's literally the entire point of my tangent I just went on. So 10,000 neurons. So scientists can do a pretty good job at actually mapping out where those neurons are in its body. So it doesn't have just one like central brain. It has other neurons, other receptor cells included in that 10,000 all over its body. So scientists with this sea slug that has a lot simpler nervous system can map it out entirely, versus humans have like 100 billion cells, neurons. That's a lot. That is well beyond what I am capable of comprehending. If I had $100 billion as opposed to the $10,000, I would still buy the Yamaha Tenere 700, but I'd probably buy some other cars too. And finally pay off student loan debt, right? Sorry to bring that up. That probably triggered harmful memories for you just like it did for me. So I apologize. The point of the sea slug, I should probably just keep clicking and keep talking rather than getting distracted. The sea slug has a natural evolved reflex to retract its gill, because its gill is a very sensitive part of it. It's a very essential part of its breathing, right? So on its back, so its gill on its back when it's poked. So I think this might be its gills. I'm not actually sure though. This might not actually be the exact right sea slug too. But it is a sea slug, and when you poke its gill, it will retract it because it doesn't want it to get eaten. It doesn't want to get damaged. It wants to live, right? So you can condition, using behaviorism, you can condition the sea slug to not care about the poke. You can make that an extinct behavior. So poking it enough time without anything bad happening, reinforcing it after poking it. If it doesn't retract its gill, give it some sort of reinforcement. So you can condition it so it no longer cares about being poked. So now there is no longer a connection. You poke the sea slug, it no longer retracts its gill. So there's the neuron sense of getting poked, but there is no longer any signal to go and retract the gill. So part of that neural network has been changed. So then you can start to apply a shock to the tail when you touch the gill. So now you are training it, retraining it to be essentially afraid or try and do a survival instinct when you touch the gill. So after that new conditioning, so you conditioned it to not care about being touched, and then you reconditioned it to be afraid or to have pain when it gets touched. So at that point, it will then really violently and quickly retract that gill to even a very light touch. That even beforehand, with the natural behavior of retracting its gill, at a very light touch, it may not have retracted its gill. But now, any touch at all will make it retract. So why do we do this torture to this creature? Well, because with the mapping of those 10,000 neurons, we can actually watch the neurons make new connections with each other and map that memory being created. Basically, map that neural network of first having a signal, the receptor cells sending the signal, hey, I got touched, hey, retract the gill, so they can watch, scientists can watch that signal be sent. Then through conditioning, they can watch that signal die off. So it's no longer sending a signal to retract the gill. Then they can watch as it relearns to retract that gill. So this taught us a lot about how we as other animals make memories. And it's in a similar way. Basically, the connections between these neurons get strengthened. The pathways for the signals, it becomes faster. It's easier to activate, to trigger that next neuron in that network as you create memories. So that is, the sea slug is really important in how we learned about these neural networks and how we create memories. So with that, the new memory for the sea slug lasted even hours or weeks. So it was a pretty, it was very similar to a long-term memory. It was persistent. It stayed with them for a long time. The gill itself also releases the neurotransmitter serotonin at the synapses. So with that, it's basically the message that it's getting shocked. So the gill itself, as another part of that network, will tell it, the rest of the body at the same time, hey, I'm getting shocked, even if it's getting shocked on its tail. So it's learning a new response, essentially. It's making a new memory because of learning that new response. And we can actually map that in these sea slugs. So that connection between the neurons in the tail and the gill means that with that tail being shocked, it's also activating other parts of that neural network when the rest of it's getting activated. So that's kind of what happens with memories. You remember your first kiss, and it might also bring up the memory of the breakup with that person, right? So because those are kind of connected, that those neural networks are intertwined. It might not be for you, obviously, but just as an example, two things that might share some of the same neural networks. So when two neurons get activated at the same time, they might form a connection. So two parallel neurons that are next to each other in your brain, if they're both being activated, they are more likely to connect dendrites and axon branches and form a connection. So with those connections together, it helps to establish highways or lots of multiple paths for these messages to go around. So essentially that's the building of these networks. And so the brain remembers by reactivating and recreating this same or a similar neural pathway as when that event happened. So when you are remembering any of those events in your past, you are reactivating some of those neural pathways that were active at that time, which is pretty neat. So memories, again, are not in one specific part of the brain. There are specific parts that help activate kind of these neural networks, especially when you're asleep, to like strengthen them and make sure those connections are made and strong, and the neurochemicals are being released so that memories are formed. But it's not just like your memory is in these couple, like 5 neurons over here versus these other 5 neurons are another memory. Probably all 10 of those neurons are part of another 1,000 neurons that are part of a couple hundred memories even. So here we've got our frontal lobes. where a lot of episodic memories are stored. So the episodes, what happened when my brother broke his arm pole vaulting, what was happening around, where was I on the field, what was I looking at, who was I talking to, what was the weather like, those kinds of things are often stored here. The amygdala, one, it's active with emotion, it's helping you feel those emotions, it's part of that process, but it's also going to also be activated when you're remembering those things. So when you're remembering the like worry and kind of anxiety of seeing my brother like falling while he was pole vaulting. Basically, he had put the pole in. I mean, I don't know if any of you even know anything about pole vaulting, so maybe this additional explanation isn't helpful. But essentially, a pole bends or should only be bending one way, and that way to bend it is the way that it will help carry you up and over. If your pole is turned like slightly off centered or even backwards, it bends the wrong way and can kind of fling you off the wrong way. And that's what happened to him. It flung him off to the side, too far away from the mat. So he fell partially on the mat, partially on the concrete. And so it broke his arm. Um, so my amygdala, when I'm remembering that, is literally feeling, it's having me actually feel some of that same emotion because that's part of the neural network that that memory is part of. So temporal lobes, explicit memory, priming memories, cerebellum as well. So a lot of these areas of our brain that are involved in the actual actions are also involved in the memories themselves. So for that, these memory retrieval information, it's really relevant to our discussion on memory tips. So this is a little earlier than I was planning to break off into groups. Just debating how much further to go. Yeah, I think this is probably the best place to stop after storage and memory, even though this is a little earlier than I intended. And then next time in class, we'll have plenty of time to talk about memory retrieval, memory tips for life. We'll probably review a little bit about how to make memories, but actually this is relevant to this point. The serial position effect is one thing for, we tend to remember things at the beginning of something and the end of something. So you are most likely to remember things that happen at the beginning of this lecture and the end of this lecture. So one of the things I want you to remember is about neural networks being how we remember things. So one thing that could help you remember that is actually having that be the last thing we discuss. So, but now the serial position effect is the last thing we're discussing. So hopefully I didn't just undo my intention there. So next time we come back, so next Tuesday, we will talk about memory retrieval. We'll talk about memory tips for life and how a lot of the cognitive psychology that we've learned about memory can help us in things from remembering people's names to remembering shopping lists, talk about mnemonics, talk about a lot of different things that can help you with your studying. So that'll be relevant to your schooling and to your future life as well. So we'll talk about that on the 10th. And we should also have plenty of time to even go over the study guide in its entirety. So do please come to class on November 10th, having gone through the whole study guide, answer the questions to the best of your ability, come ready to ask questions, and then I think we'll have time to be able to go through all of Unit Exam 3 study guide. For now, this is a little longer than I intended, but I want you to have some time in class time. If we were actually in a building, I would essentially just say, hey, break off into your groups right now in the room and meet together. But since we're in this online format, I'll essentially just turn off my mic and camera and let you guys all jump into your group team area. Or if you wanted to go and have a Google meeting, with that, in these teams, in these rooms, don't forget that you can start your own meetings in there. So if you've got 3 of your 4 group members or something like that, do a video chat meeting, make next steps. As a reminder, the group presentation is due on December 5th. So that is coming up. That's about a month away. As you probably realized, October went really fast, and so November will probably go pretty fast too. So it'll come up pretty quick. So what you should be working on now is definitely you should be working on slides. So maybe just the beginning, you're kind of organizing it. You say, okay, I'm taking these first 3, you take the next 3, that kind of thing. But you should definitely at this point be working on slides. Find other content, additional content outside the book if you want to. You should already know what your kind of focuses will be. So maybe finding other resources, articles, relevant websites. So that's kind of what your plan should be today with your group. So take this time to work with your group, set out goals, definitely set a next meeting time. So if you're all going to meet tomorrow, set a next meeting time, or if you're going to meet on Saturday together. And don't forget, you can use the Microsoft Teams at any time to come and meet. So if you wanted to meet on Friday at 2 o'clock, if that worked for everybody, you can meet in your Microsoft team Friday at 2 o'clock. So before I turn off my mic and camera, I'll still be here to watch the chat, but I'll stop the recording, and I'll be available for answering chats and whatnot, or messages. And I might jump through the other meetings to see how students are doing and how far you are and things like that. But are there any questions before I let you go and work in your groups? Hopefully most of your group members are here. Looks like we've got 15 students currently in the class. So if there's members of your group that aren't there, I can show you this right now, actually. So if there are members of your group that are not there, you can type their name in and invite them. So if they are in your group, so let's say Christopher Maya was in your group, you could literally invite them to it. You could say, hey, come and join a meeting right now. So you could do that to help encourage them to come and join, to see if they're available right now. All right, I don't see any chats coming up or any hands. So I'll let you go and jump into those meetings. Again, I will be here. I'll just have my camera off and my microphone off. So I'll be watching for the chat, and I'll be kind of jumping in between the different teams to see if there's anything I can do to help. But you should definitely be working on slides at this point. You should definitely have assignments and be meeting pretty regularly, if not every week, every other week, because December 5th will catch up to us, and that's when the presentations are due. Yeah. All right, well, thanks for being here in class today. We will talk more about memories next time. Go and get some good work done with your group. I'll let you get to that. Have a good night.